Hi, I'm Carl Host from Lincoln Electric, and I'd like to welcome you to another MasterClass from ARC Magazine. Today we're going to be talking about cracking in aluminum welds, and particularly when we're welding on the 6 series aluminum alloys. 6 series alloys are predominantly used as extrusions, also as plate, and when we weld on those, we weld them with a filler metal of a different composition than the base metal is. We usually weld them with either a 4 or a 5 series filler metal. And it's very important that we get adequate dilution of the filler metal in order to prevent solidification cracking on these materials. Today we're going to be welding with the new square wave TIG200. And this machine is capable of welding on AC and DC. AC is what we're going to use for aluminum welding today. There's a balance control. It goes up to 85% negative, down to 60% negative. Also has a frequency control where we can adjust the AC frequency from 60 hertz up to 150 hertz. Whenever we're welding, we always want to make sure we have adequate ventilation. Today I'll be wearing TIG gloves, which are red line TIG gloves. Thin leather gloves, protect my hands from hot metal and UV light. I'll also be wearing a Viking welding hood, which is going to have a shade 10 lens, or it's adjusted for a shade 10. I'm wearing long sleeve fire retardant clothes for UV protection and burns. And I'm also wearing safety glasses with side shields. Those are ANSI approved safety glasses. There's a number of ways that metals can be joined together. There's an open corner joint here, there's a T joint here, there's also a lap joint. When we're welding on 60 series aluminum, we should always be using a filler metal when we're making this type of joint. There's also a butt joint, which are put together like this. And a butt joint would have to be a full penetration weld in order for it to be full strength. Sometimes when we fabricate structural aluminum, which is often 60 series, we might cut miters and fit pieces together like this. Well, that's a butt joint. That's a square butt joint. And welders know that they can penetrate all the way through that butt joint. But when they do that, you're going to get a lot of base metal mixed into that weld. And they don't make 60 series filler metal for a reason, because all the welds would crack. It is prone to solidification cracking. And by adding a filler metal of a different composition, we can change the chemistry of that weld metal and not get that crack. So the recommendation here is we're going to miter and fit these two pieces together, is we will bevel the two pieces, and that'll allow us to get plenty of filler metal in that composition. Okay, I'm going to use an illustration on the board here to try and show you how these cracks happen and how we can possibly prevent the cracks on 60 series aluminum. Here's a typical T joint. And when we weld a T-joint like this, in order to get adequate strength to the weld, we add filler metal. And if you look, this black area here would be all the filler metal that we added. And of course, in order to get fusion, we also have to melt some of that base metal. Well, if you look at that picture, you can see there's quite a bit more filler metal than there is base metal. And that weld will not be prone to cracking. The 4 series filler metal, or 5 series filler metal for that matter, will change the chemistry of that weld deposit so we don't get a crack. When we do a lap weld, same thing, it's a fillet weld, but we have to be careful with lap welds that we add plenty of filler. We don't want to melt this corner down and use very little filler metal. That weld will be prone to cracking. The other type of joint, the butt joint, which would be like taking two pieces like this and putting them together, would mean I would have to melt all of this base metal. This pink area here you see is the base metal, and that little gap, the black area, is the two pieces where they're butted together, and we add a little bit of filler metal on the top. And as you see, the composition of that weld, when all that metal is mixed together, is going to be more base metal than filler metal. And there's a good chance that's going to crack. If we bevel the pieces first, we put a 30-degree bevel on each side, or a 60-degree included angle, we can get plenty of filler metal in there and change the chemistry of that weld nugget or that weld deposit so it's not crack sensitive. We also have to be careful at the end of the welds to fill the craters, because concave hollow craters will also tend to crack. So we have to add plenty of filler metal at the end to fill that crater up. So for our demonstration today, we're going to simulate welding some structural hand railing made out of 6061. I've got two pieces that I've beveled. They have about a 30-degree bevel on each side. Gives me a nice opening there to get some filler metal down inside there and change that composition. I've also done two the wrong way, where I just sawed them and I'm going to butt them together. This is 6061 T6 material. It's a little over 1/8 of an inch thick. So penetrating down inside, I'm going to get quite a bit of base metal in that weld on this one here. For today's demonstration, we're going to weld this 6061 T6 pipe up with a 4043 filler metal. It's a alloy with approximately 5% silicon. It's an aluminum silicon alloy. There's a couple of different 4 series filler metals that would work. Also, there's some 5 series filler metals that would work as well. I'll be using a 332 diameter filler wire. 332 or 1/8 would both work quite well for this. The first fit up is going to be a square groove weld, fit tight together, and I'm going to try and penetrate in. I'm going to get very little filler metal in this weld, and this is the one that's going to be prone to cracking, so we'll see how it does. I'm going to tack with about 165 amps. I'm going to control my current as I go. I suppose I'll be running somewhere between 130 and 160 amps. We'll adjust on the fly here with the foot pedal. So the key to welding 60 series aluminum is to make sure that we get plenty of filler metal of a different composition into that weld. 6061 aluminum is very weldable if it's welded properly. With the beveled joint, I'm able to get more filler metal in that weld deposit than I have base metal. When I went with the square groove weld, I penetrated down into that base metal and melted all that base metal, added very little filler metal. It's resulted in a solidification crack down the middle of that weld. Sometimes you'll see that if you look at hand railing at amusement parks and things like that are made out of aluminum, where they miter cut and weld afterwards. Sometimes they sand those welds off, and you'll see right where the weld used to be, and there'll be a small hairline crack. And that's usually the result of not beveling that aluminum before you weld on it, or opening it up so you can get plenty of filler metal in there. Thanks again for joining us for ARC Magazine's Masterclass. I'm Carl Hose. We'll see you next time.